Hello friends, today we'll demonstrate the tan delta test for transform oil setup and capacitor bank. Another name for this tan delta test is nothing but a loss angle test or dissipation factor test. Why this test is performed? Actually, in the insulation, in ideal condition, the capacitive electric current leads the applied voltage by 90 degree. But in the practical condition, due to the aging effect of insulator, because of the impurities like dirt and moisture enter into it, that insulator cannot be made 100% pure. So these impurities provide the conductive path to the current. Consequently, leakage electric current flowing from line earth through insulator has also resistive component. By using the tan delta test, we can measure the impurities or resistive component of that particular current. Now we'll see the working principle of tan delta test. In tan delta test, sharing bridge concept is used. For this, you can see at the place of Z1, transformer oil setup or capacitor bank is placed, and the value of C4 is varied to balance this bridge. If the bridge is balanced, then we'll get the values of C1 and R1. Accordingly, we'll calculate the value of tan delta. Okay. Now we see the practical kit. This is the tan delta kit. Here you can see the different mode, that is C and DF mode. C means capacitance and DF means your tan delta mode. Okay, so these are the knobs. This is the multiplier. Okay, then this is the course, and then fine for the C. Similarly for the tan delta. This is the course and this is the fine knob. This is used for the balancing this sharing pitch. So these are two terminal H and L. In this experiment we perform only the UST mode only. So this is the capacitor bank. You can see here you have to connect this L terminal to different capacitor values and H terminal to this H terminal of that our tan delta kit. Okay. Similarly, this is the your transformer oil tank. So these two H and L terminals. You have to connect this terminal to this kit, that is the H and L point. Okay, so this is the complete setup of the tan delta test. Now we perform this tan delta test for the capacitor bank. So first we have to connect this capacitor bank to the tan delta kit. Now connect this H to the H and L to the H terminal. So we'll select the first points of capacitor to the L and H of this capacitor to the H of this kit. Okay. So before start this kit, we'll see the calculations. So for the capacitance, you have to multiply value into course value plus 5 knob by 1000. Similarly, for tan delta measurements, first you have to set the minimum value plus maximum value into fine knob upon 1000. Okay, so these are the measurement of capacitance and tan delta procedure. So now we'll apply the voltage to the tan delta kit. Now switch on this button. Okay, you can correct this one. Okay, now it is start. Select the mode of operation, that is we'll select the C mode. Now we'll move the first multiplier. You can see the change. I will select the first 500 pico 1000. Now we can see the change in between 20 and 50, and now we can move that course. After course, we'll select the we'll move the fine. Okay, again just do like this and balance this sharing bridge. Okay, so you can see now this bridge is balanced for C mode. The multiplier is nearly 50 picofarad, that is course is 3 and fine is 999. Okay, so similarly for df, that is tan delta, same procedure is should be follow. We have to first move the course and then your that is fine for the balancing this sharing bridge. Okay, you can see the bridge is balanced. The value is 10 to 20% of tan delta is there. Okay, so minimum value is 10 and maximum value is 10, 20 and 204. Okay, so this is the experiment for the first capacitor value. Similarly, we'll select that value. We connect this L terminal to the B of B, that is second capacitance value, and same way we'll follow this procedure. We'll turn on this switch and we'll balance that bridge for C mode and tan delta mode. The same procedure should be follow. Okay, then course, you can see the procedure. Just you to balance this bridge. For this you have to use the course and fine off. Okay, so now you can see for the B points, that is B capacitors, this value of the multiplier, course and fine off. Okay, you can see here this 39 is fine. Now same way procedure will follow for the tan delta. Okay. So same procedure will follow for tan delta. You can see now it is balanced for the that is for that value is tan delta is second is wrong, that is 1 to 10. 1 is minimum and 10 is maximum. Now same way for the third C point, you can see the same procedure you have to follow. You have to balance the sharing bridge for the C mode and DF mode. You can see just you have to follow the same thing. What you are doing, you are balancing, you are varying that capacitors of the fourth branch of that sharing bridge. Now for same for DF mode. Okay, now use the course. Now it is balanced. You can see, you can note down these values. There is 1 to 10, that is not 0 to 10. Same way the last that is the last value of this capacitance. You can see now same way you have to follow the procedure. You have to just balance this bridge. It is balanced. Now same for the DF. Note down these values, the multiplier, course and fine knobs. Okay, 100 picofarad for multiplier. Same way for the DF, that is the tan delta mode. It is balanced now. Okay, now these all the values for this capacitor bank. Now we'll move further. We'll Connect the first we'll connect this transformer oil tank to the that 10 delta kit. Now first you have to connect the H terminal, you can see, and you have to connect the L terminal. Okay, so now it is connected. Now you have to start these both 10 delta kit and transformer oils. Now turn on. Now same way, same procedure you have to follow, just balance the bridge. Check, make the 0. Actually this transformer allow more impurities, so that their value is very less, so you have to select that 20 and nearly very less capacitance. Now you can see the coarse fine is 0 and coarse is 0, fine is 194, and your multiply is 20 picofarads. Same way now we'll see, we'll balance the 10 delta. You can see here this 10 delta value should be very high here. Now you can balance this one. Okay, so in this way you can balance this, you can perform this 10 delta test for the transformer oil and capacitance bank. Now we'll see the observation. Okay, so these are the observations for the 10 delta test. You can see the values of capacitance for the capacitor and transformer oil, and same way you can in the next table we'll see the value of 10 delta. Okay, you can see these are the values. Uh, Same way the value of 10 delta is, you can see here it is 7.05%, 3.85%, and for the transformer oil setup it is 28.16%. Okay, so this is total demonstration of this experiment. Thank you.